25 equals 70 minus 5x. This implies that 5x equals 70 minus 25. This implies that 5x equals 45. This implies that x equals 9. So, therefore, from the equation 1, that is, x plus y equals 24, on substituting x value we get 9 plus y equals 24. This implies that y equals 24 minus 9. This implies that y equals 15. Therefore, the missing values over x and y are 9 and 15 respectively. Now that we have seen three measures of central tendencies, let us see which measures of central tendency would be best suited for a particular requirement. The mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes, that is, the largest and the smallest observations of the entire data. It also enables us to compare two or more distributions. For example, by comparing the average, mean, results of students of different schools of a particular examination, we can conclude which school has a better performance. However, extreme values in the data affect the mean. If one class has frequency, say 2, and the 5 others have frequencies, 20, 25, 20, 21, 18, then the mean will certainly not reflect the way the data behaves. So, in such cases, the mean is not a good representative of the data. In problems where individual observations are not important, and we wish to find out a typical observation, the median is more appropriate. For example, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there. So, rather than the mean, we take a median as a better measure of central tendency. These are the situations where extreme values may be there. In situations which require establishing the most frequent value or most popular item, the mode is the best choice. For example, to find the most popular TV program being watched, the consumer item in greatest demand, the color of the vehicle used by most of the people, etc. Remarks. There is an empirical relationship between the three measures of central tendency. 3 median equals mode plus 2 mean. The median of group data with unequal class sizes can also be calculated. Now let us see some exercise problems. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean, and mode of the data, and compare them. Solution. Given number of customers, n, equals 68. First we need to find the mean of the given distribution. In order to calculate the mean, let us now calculate the class marks for each class interval. Let us consider the class interval is 65 to 85. Here, 65 is lower class limit, and upper class limit 85. As we know that, class mark equals upper class limit plus lower class limit, by 2. This is equal to 65 plus 85, by 2. This is equal to 150 by 2. Therefore, class mark equals 75. Similarly, class mark for the other class intervals is calculated. Let us consider the interval is 85 to 105. Here, upper class limit is 105, and lower class limit is 85. As we know that, class mark equals upper class limit plus lower class limit, by 2. This implies that class mark equals 105 plus 85, by 2. Equals 190 by 2. Equals 95. Let us calculate the calculation of class mark for the other class intervals in the shortcut method. That is, as the class size is same for all the class intervals, that is, 20, we can get the class mark by adding the class size to its previous class mark. As per our calculation, the previous class mark obtained is 95, So the next class marked for the class interval 105 to 125 is obtained by adding the class size, that is, 20 to 95. Therefore, class marked for the class interval 105 to 125 is equal to 95 plus 20 equals 115. Similarly, class marked for the class interval 125 to 145 is equal to 115 plus 20 equals 135. Class marked for the class interval 145 to 165 is equal to 135 plus 20 equals 155. Class marked for the class interval 165 to 185 is equal to 155 plus 20 equals 175. Class marked for the class interval 185 to 205 is equal to 175 plus 20 equals 195. As the class size is same for all the class intervals, we can use assumed mean method or step deviation method to calculate the mean of the given data. Therefore, the given frequency distribution table combined with all class marked for each interval as shown in following table. Here, we are using the assumed mean method. To calculate mean by using this method, we need to know the assumed mean A and the deviation. The given observations are 75, 95, 115, 135, 155, 175, 195. The center value from the above given observations is 125 and 200. Therefore, A equals 135. Let us consider the class intervals 65 to 85, 85 to 105, 105 to 125, 125 to 145, 145 to 165, 165 to 185, and 185 to 205. Here, we observe that each class interval difference is 20. Therefore, the size of the class, or class size, H, is 20. We calculate UI by using the formula UI equals Xi minus A by H. And also find the product of FI and UI. Let us consider class interval 65 to 85. Here, Xi equals 75. Then UI equals 75 minus 135 by 20. This implies that UI equals minus 3. Now FI UI equals 4 into minus 3, since FI equals 4. This is equal to minus 12. Similarly, we calculate for the other class intervals. Let us consider class interval 85 to 105. Here, Xi equals 95. Then UI equals 95 minus 135 by 20. This implies that UI equals minus 2. Now FI UI equals 5 into